Yeah. Thank you.
Okay, thank you, thank you. The fourth presentation is given by Pavel Kogut with his presentation titled Using a Local Digital Twin to Build a Positive Energy District in Aarhus. Welcome, Pavel.
Hello, Juan. Hello, everyone. Nice to be here with all of you guys. One more thing I need to do before I start is try to share the screen. And do let me know if you can see it.
The presentation.
Can you see the screen?
Yes, yes, good.
All right, perfect, great. So the title of my presentation is focusing on the efforts that a city in Denmark, the city of Aarhus, the effort that the city is undertaking to reach climate neutrality with the help of a positive energy district and local digital twin technology. And let me start by saying that Aarhus really has a long history of working towards climate neutrality. A year after Kyoto Protocol, there was a conference and they came up with 7 statements on how to address climate change. Post-Kyoto, the recommendations that were delivered to COP15 at the time. And then more recently in 2022, Aarhus joined the club of 112 cities that include EU cities and international cities as part of the city's mission. And last year, the city also adopted its latest climate strategy, where it articulates and sets out the plan for reaching net zero emissions by 2030. But this climate strategy also includes a warning. The city of Aarhus currently emits about 1.3 million CO2 equivalent, spread across different sectors, with transport accounting for more than half of emissions, followed by energy waste, agriculture, forestry, other land users, and industry. And the strategy is saying that if there are no changes to how we do business, basically, if we continue with business as usual scenario, we're going to offset only 1/3 of the current footprint. But if we really want to offset the entire footprint, then we need to really test novel ideas. We need to scale solutions that prove their worth, that are tried and tested. So there's a lot of initiatives going on there. There's a new carbon capture plant being built. There are plans to increase geothermal share in the energy mix, decarbonizing transport, electrifying transport, the spread of solar panels on roofs of residents, office buildings, buildings owned by public authorities. All this is part of the efforts. And also one interesting effort there is the positive energy district. And let's briefly talk about positive energy districts and what they are. Well, these districts are self-sufficient with energy. They reach energy surplus by producing more energy than they consume during the year. And there are various ways in which PEDs can be achieved. There are several requirements for PEDs to be established. So PEDs, first and foremost, they try to minimize their energy use. And of course, when we talk about building stock, this refers to energy efficiency improvements in buildings. PEDs also tap into local renewable sources, wind, solar, geothermal, wastewater, and so on and so forth. PEDs, they leverage distributed energy sources like EVs, like energy communities, and they also share the surplus with other areas. So not only do they plug gaps within the district, so transferring energy from new buildings to old buildings that are less energy efficient, but they also take the surplus that they generate and share it with other districts. Now, the chosen district in Aarhus is called Brabrand. That's one of 6 districts that city has. It's not particularly densely populated. There are only 20,000 residents in Brabrand. That equates to around 6 or 7%, because the total population of the city is about 300,000. And the Brabrand has a very diverse socioeconomic profile. It has a lot of different building types. There are office buildings, there are public offices, there are different types of companies, SMEs, industries, large corporations. Also, in terms of who lives there, there are a lot of people from migrant background. So quite a mix. One area in Brabrand district, one neighborhood, is known for its old social housing estates that were built in the 1960s called Gellerup. So there, a big regeneration effort is underway to transform this neighborhood into a vibrant community. So, for example, the Gellerup neighborhood that I mentioned, a lot of these social housing estates that were built in the 90s are now being demolished. Some of them are retrofitted, and the new residential buildings are being built there that are fully compliant with the climate ambitions of the city. An interesting development taking place in Brabrand is the establishment of an energy community, the first of its kind in Brabrand, and it was set up less than a year ago. It's called Sol over Brabrand or Sun over Brabrand, and the intention is to install photovoltaics on roofs of residents, on roofs of businesses, and also on roofs of buildings owned by the municipality, and ideally share this electricity within the members of the community. However, there are some challenges that prevent this from happening, and at the moment, the Danish law basically prohibits members of the energy community to trade electricity with one another. They can sell the excess electricity generated from their solar panels to the grid, but the credits that they get from net metering are not particularly favorable. So what the energy community is doing now, it's currently trialing basically a data exercise where they're not trading any electricity at the moment. They can't because of the law, but they are just trying to capture their energy consumption and share it with the members of the community, just to see what the potential is likely to be if the law softens and they're allowed to trade electricity later on. So we covered the PEDs, what they are, and the different PED-related, PED-oriented activities in Brabrand, but they are also using a local digital twin to support energy transition in Brabrand and Aarhus more widely. Now, most of you probably know local digital twins, although perhaps by a different name, because it's really been a buzzword for last few years. Sometimes they're referred to as urban digital twins or virtual cities or digital twins of cities. So despite all the different names, they really serve one shared purpose, and that is to improve the way cities are planned, improve the way cities are built and managed. So really covering the entire spectrum of the urban governance cycle. And now, of course, there are a lot of use cases that can be mentioned, and this presentation is not long enough to mention all of them, but really there are examples of how digital twins are being used by cities at all these different stages. In the planning, for example, they can help you create first-time right designs that comply with planning regulations and energy and policy goals of the city, and doing it the right way so you don't have to then make costly corrections afterwards. Digital twins are used to streamline planning applications. The whole planning approval process becomes model-based, so you don't send any PDFs anymore, making it really efficient. During construction phase, if you have a digital twin of underground facilities, for example, you can avoid damaging all the cables and pipes, which still happens very often. And because construction is a complex process with many moving parts, if you have a digital twin of construction that connects multiple systems of different actors involved in construction in that value chain, you can improve coordination and deliveries, minimize cost overruns. Finally, in management, lots of different use cases exist, but a few that can be mentioned is, for example, sewage control to minimize overflows and prevent overflows, optimizing traffic flow with smart signaling systems. So the list really goes on and on and on. And what local digital twins do is they provide this virtual representation of physical assets and processes that are happening in a city. And depending on how sophisticated a digital twin is, it can also affect physical reality through actuators and this two-way exchange between the virtual world and the physical world. And some systems in the cities, they're so critical, you cannot really switch them off to test new things, like energy transformers. You cannot really switch them off to see if a transformer can take on additional load. But if you have a digital twin of a transformer, then you can simulate that and see if it's possible to load the transformer with a few more voltage for several more hours without crossing that temperature threshold. And last but not least, when we talk about the benefits of digital twins, is that yes, they can be very complex systems, but the beauty of them is that some elements of the digital twins can be used by citizens. So citizens, for example, like members of the energy community, they can go to the digital twin and see if the building has enough solar potential for them to engage in this activity. Aarhus, along with other cities, is mentioned in the forthcoming book, Decide Better on Local Digital Twins. It's an open source book that will be available next month. So in case someone is interested, you can scan the QR code and enjoy reading it. But back to Brabrand, what we do have at the moment when it comes to a local digital twin. We already have a prototype solution that uses the semantically enriched CityGML model of the city. We are using OpenGeospatial Consortium standards to ensure that models of energy, models of traffic, for example, models of air quality can interact with one another when we start doing the simulations. And also we're using DCAD AP standard to ensure that the data sets can be discovered by different systems and shared across border as well. Now, we've managed to successfully get energy data from Kretslop. That's the utility company that provides district heating to residents of Aarhus. And we are going to use this data to see what gains can be achieved by further increasing the share of district heating in the city. Most of the residents already use district heating, but not all of them. So we're going to see what gains the city can achieve by increasing district heating and also by increasing the geothermal energy in the energy mix. Geothermal has big potential, but at the moment it represents less than 5% of the energy mix. Now we also want our digital twin to have a social component. We obtain data from municipality to build the social democratic profile within the digital twin. So we obtain data sets on age, gender, citizenship types, housing types, but we couldn't do it on a household level due to privacy concerns. We had to get aggregated on a certain scale to overcome these privacy restrictions. And finally, we also received data from TomTom. This is a floating car data because one of the goals is to decarbonize transport. As I showed in my first slide, transport accounts for more than half of the emissions in the city. So we're also using traffic data to run macroscopic model simulations. But we do encounter some challenges. The data from TomTom, for example, that I mentioned covers city's traffic only partially, at maximum a quarter of the city traffic, which prevents us running proper citywide modeling. And we, in addition to the social data sets that I mentioned in the previous slide, we requested a few more data sets on employment and income because we are interested in checking the potential for spreading renovations in all parts of the city. But of course, renovations, they cost money, and we know that cost is a big barrier to renovations. So we want to see where exactly in the city renovations are more likely to happen using the socioeconomic data, where also rooftop photovoltaics are more or less likely to be installed, and how different demographics are going to respond to price signals, and whether they're going to change their habits in terms of ventilation use or heating use as a result of that. So in conclusion, what I'd like to say is that PED has promising potential, but for example, in Brabrand, we're at the start of the PED journey. There are still issues of scale, how we're going to scale a positive energy district, starting from individual buildings, then growing it onto a street level before finally encompassing the entire district, which has multiple land uses. There are various challenges related to data and challenges related to establishing energy community. Hopefully this will be overcome, and integrating the digital twin technology and taking advantage of all the benefits that it can offer. We believe that there is really good potential to advance energy transition in Aarhus and make this journey green, digital, and fair, meaning that everyone can take part in this transition, including citizens. So I'd like to say thank you for listening, and We are a European funded project that has a website, has social media profiles. And if you are working on PEDs or if you have any questions on PEDs, we would like to engage in a conversation with you. So thank you once again.
Thank you, thank you. Thank you, Pavel, for your presentation.